think they're supposed to be sour.
It's weird.
It's a citrus, I don't know, is it?
Is this citrus sour?
It's,
I thought that's bitter.
No,
it's,
bitter is sour.
Yes.
Bitter is bitter.
Yeah.
Bitter is Goya.
yeah,
Ah,
that's
you're right.
citrus.
You're right. That's funny. Just the names for how we describe the flavor or the what it does to our face.
Probably better to make it slightly
Oh, right.
brighter. Yeah,
So
so I probably will use the.
From my side, it's a little bit too bright to see your presentation.
Ah, okay. I see.
If you're using the board, maybe it should be on that side.
The camera's over
Yeah.
here,
Uh-huh.
Okay.
so switch.
Kazuma も前に来る Would you like to?
Yeah, for this one.
いい
Okay.
Musical chairs.
Are we pushing people out?
カバンそっち側にもしていいですか
あ、はい。
My.
You wanna sit up there or back here?
If you can also
Whatever
activate
you
the
would have to
transcript,
Transcript?
yeah, and the Zoom.
I can turn on this transcript, should I?
Because sometimes I recently I actually used that output to input to GPT to get summary.
すごい。How do you?
It's actually nice.
So like later on, there will be transcript, right? Or should I do something in the Zoom?
Allow.
On Zoom, there's probably option for.
Mention there, the COI. Is this also the paper?
So we're recording, we are already starting, yeah? We're already late, yeah? Yeah.
I'm sorry?
Sorry, we're.
Yeah, sure.どうぞ。
Please.
All right.
Welcome to the seminar.
Yeah, hello. I just started my name is Nao Tsuchiya. I'm from Monash University, and I just started the TVSP fellow like 2-3 weeks ago, and giving the TVSP talk this week. And I had several exchange with Tom over years, and yeah, today after having some kind of lunch chat, we thought that maybe it's interesting to talk about the connection between what you guys are doing and also other kind of approach to the causality, especially from IIT. And this is a particularly interesting paper, I think, to discuss. So that's why I suggested this one. Before starting this, maybe can I ask how many people have actually read this paper? You.
Skin, yes.
And how many people are familiar with the notion of causality? How many people have seen or encountered the IIT, integrated information theory? Okay. All right, then yeah, maybe I'll just probably walk through what this paper is about, more or less. So this paper is talking about the title is really pretty much what this paper is about. It's a distinction between the causal reductionism and the causal structures. And although this paper doesn't explicitly say anything about integrated information theory of consciousness, it is building based on the architecture of this integrated information theory to build another kind of fruit sort of coming from this formalism, which is the theory of the causation. And with that, Tononi and the other people actually think that many of the problems in the so-called causal reductionism can be resolved to give more useful framework to explain or understand what is causing what. And this is very difficult to understand in the reductionistic framework. So that's a sort of the essence of this paper. And can I? And then interrupt me at any point if anything is unclear. Okay. So by causal reductionism, so this paper also focuses 3 things. It's probably clearly written in this box 1, causation, prediction, and supervenience. How many people are familiar with the prediction? Probably that's very, they are intuitive, right? But the supervenience? No.
You should know it,
I
Pranshul.
didn't completely understand it. So. But yes, I'm taking his course, so I've come across this term.
Roughly speaking, what do you think supervenience means?
Roughly speaking, I think it just means emergence, but it's very odd that they, it's different from identity, but it's not the same. I mean, they just give it some extra space for it to exist. I don't know.
Okay.
So I don't really understand this term.
Yeah, so these 3 things are quite difficult thing, especially philosophically. But this paper gives a relatively clear understanding, I think, especially if you read this box 1. And if I remember correctly, all of these things are sort of model of the understanding according to human. So the prediction, that's probably easy. Prediction is basically if you have some kind of a state of the things, like let's say, x at time t, then you can predict what this x is going to be at t plus 1. That's a prediction. And then causation and the supervenience, maybe next one is that supervenience. And then supervenience is in this sense, this is kind of horizontal direction, right? And then the supervenience is more to the vertical direction of the things. If you have a unit x at t and a y at t, then you can jointly also understand what's this x, y thing at t, right? I mean, what do you, if you have, 2 things, and then if you try to give a joint explanation about both, then that is this. So basically, this vertical kind of determination, and in more simpler terms, let's say if you have molecules of all the cells, and then eventually you should be able to talk about the state of the cell. And then if you know all the state of the cells in the body, and then you should be able to give an explanation about the state of the body. And the same goes for neurons, right? All the neurons recording, if you know, and then at that moment you can talk about the state of the brain.
Now, is it the case that a Boolean function is an example of supervenience? So let's say like an AND function. You have 2 variables, x and y. They could be either true or false, as the other one. And then the AND function tells you only 1 if both of them are 1, otherwise 0. Is that AND function, would that be called?
At time t, yes, I would say.
But you will lose information, so you cannot recover. So that supervenience means that you can reconstruct lower level from upper level.
Yeah, from low to back.
But
yes.
can you
From low to upper, not from
reconstruct back?
But you can never do that, right? You always lose some.
I mean, Fernando will disagree.
I think, no, I don't think so.
So,
But for example, in the case of AND, right? Then let's say, if this is a kind of an AND operator, and then if things are determined instantaneously, then let's say if you have this kind of XY table, And then 1 goes to this, x1, maybe something like z. At all at t becomes 1.
That's what I mean, yeah.
Goes to 0.
Yeah, so the information is lost.
Yeah, but that's not the issue here, right? I mean, supervenience just means that the state of the emergent level is determined by the concurrent state of the lower level.
Yeah, so I think what he said is correct, right? So from bottom to top, determination is this, supervenience.
Would
Yeah.
it be sufficient to say that it's an injective map and not a bijective map?
I think you can say that, yeah.
So like in this case, it'll be XOR, and so 0, 1, 1, 0 will return a 1, and 1, 1, 0, like, so if an XOR results in the same state,
XOR is
it's an injective map.
right. Or map is same kind of format. It's 1, 1, 0, 1, 1, 0, 0, 0. All of this as 1, and then this is 0. So XOR, which also happens in this, paper, is gonna be this. So it's different from this. This is AND.
And all of them are case of supervenience according to this definition.
Yeah. That's correct. But, just to make sure.
Yeah.
XOR and the OR is flip side of this.
Mhm.
Right? So roughly speaking, horizontal, temporal prediction and the vertical determination, macro kind of correspondence. From micro to macro correspondence is the supervenience. And then what is the causation? Is according to this author, basically both are kind of dissociable from prediction and also orthogonal to supervenience as well. That's the point of this paper. And what it is not yet described, but so they give this funny kind of interesting organism, hypothetical organism of a frog to explain this point. This frog is, there are 3 types of frog. One is F3, another one is F2, and then third one is F1. And F1 is corresponding to 2 half of frogs. And the upshot of this is that there is a unit CLCR jointly for the first time gives some kind of causal explanation in this frog. But this one, you don't need to have something like that. So roughly, that's sort of the upshot of this. And then on the other hand, the F1 frog doesn't have any kind of joint causal CLCR. Okay. And what I try to, this is a kind of the IIT's formulation of many of the artificial units that happens in many of their papers. Roughly speaking, this first layer is the sensors. And then central units and the motors that determines the input and sensory output. In this case, all of them are feed forward. There's no recurrency.
So this is horizontal or vertical?
So far, everything is nothing to do with the horizontal or vertical. Okay, but just to say, so this is a kind of an environment of the simulated kind of world where this frog can live. And then there can be 3 different kind of bugs, left bug, right bug, and super bug. And what this rule says is that if you catch left bug or right bug, then that's actually good for frog, they can survive. But if you hit onto this super bug, then they are dead. So what you want to do is to get this, but avoid this. And so the most efficient way to get do it, this frog to go to the left for the left bug and the right to the right bug, but or jump over this super bug to avoid it. But that's a behavior that you want. And the idea is that this frog and this frog gives exactly the same behavior. Sensory motor output is the same. And the way it does is that so its initial sensors have a particular kind of feed forward input into the 3 layers, and then these 3 layers gives an output to the motor. And then that you can actually configure this wiring so that this desired output is there. And the same goes for this one. Without this central node, you can do this. So far, is it right? More or less.
Sorry.
Yep.
F1 frog is a single agent, right?
No, this one is single, and this one is single.
So they're like two separate
Two separate
hop
things.
frogs.
Yeah,
Okay.
half from each.
Yes.
But if they happen to be there and there, then the behavior looks almost the same.
Hmm.
It doesn't have a jumping over behavior, but so if it encounters with this super bug, it splits into like this, but it kind of avoids being called. Yeah. So far, fine. Okay. And then the sort of the causal explanation according to the causal reductionism is sort of similar to what the neuroscientists, most of the neuroscientists does, like a recording from CL, CAC, and CR as a neuron, and then try to show all sorts of the inputs from to the animal, and also record what the animal will do. So this is basically the same kind of fMRI or EG or single unit experiment in the neuroscience, right? And then what they find is that basically this is central unit of CL for this will react, becomes on when they see something like this, left bug. So it can be called as a left bug detector, right? And then this one is a right bug detector. And then this one is super bug detector. It becomes active only when it hits onto this super bug in front like this one. So that's fine, right? I mean, that's the way most of the neuroscientists assume things can be explained and also, things is happening in the brain. However, the problem is this one. So this guy, again, just to make sure, all the behavior is the same. But you can't say that there is a super bug detector in this case, because there is no such a thing. But this one is a left bug detector, this one is a right bug detector. And what do these reductionist people say is that this one doesn't actually have any mechanism for the super bug detection. They just kind of, according to this paper, it's called explained away. They basically ignore. And then if you ask what's causing this guy to jump over, they have no actual answer, right? However, this IAT framework gives a very specific kind of operation to say that the CLCR, this is a joint mechanism. It's called a composite mechanism. And this actually exists in this case. And this guy can be considered as a superbug detector. So the causation wise, what caused this guy to jump over is this mechanism.
Your table probably.
Copyright is ready.
Yeah, it just went to sleep.
Yeah.
So then, yeah,
Maybe.
it's gonna go.
Okay.
Just wait a little bit. So then, there is no. It says that it will go nothing. The composite one means that there is some activity in the left one and the right one, but in order to comprehend what's the behavior, you need to look at them both together.
Exactly.
Okay.
But this is almost like an AND operation, right? And at the level of AND, there is this mechanism. But it's not at the level of this each individual X or Y. That's a formulation.
So for some reason I stopped seeing you.
Yeah.
When neuroscientists look at these multi-unit recordings, they'll just run PCA or something, and then CLCR will come out as having an effect together.
I'm not sure if they would accept something like that, actually. Yeah. Because they don't know how to combine or decompose things. So what should I do? Choose content. Okay, something like that. So for example, then next component would be maybe if I should maybe I should does it make sense or do you need a more detailed example of why this exists? More is fine.
So you're saying
Oh.
using any statistical technique, you can't actually know if it's a CLCR or
Joint or no?
Yeah.
Yeah. So for that, probably if you are really interested in this thing, supplementary material actually gives a little bit of flavor of what exists and what it doesn't. And I'm not going to go to the super into the detail, but this one is telling in a sense. So thinking about this frog, F3 frogs in all the mechanism, then you can think about CL, CC, CR. Any power set of these three things can be a potential mechanism as a composite or as its own. So this one is an CL as one mechanism, and then this is CC, CR, and then this is CL, CC, and then this is CCCR. And then they consider the CLCR as a mechanism as well. Okay, this is a kind of the arbitrary combination that PCA or ICA allows you to do that. Okay, but then they end up in saying that there is no such a thing actually here. The reason is that to explain the effect from this guy to the ML and MR, you can completely consider a situation, this CL and then CR and the ML and the MR. Actual sort of the connectivity here is that this guy is giving the output into here, this guy is giving output here, right? Mm-hmm. And then it's already kind of apparent here that there's nothing you lose if you disconnect this system here and there, right? So combining these two together, like two persons, I mean, this may actually be sensitive to your guys, but two persons together or one at a time doesn't make a difference here. And therefore, this effect size of the causation becomes 0. And then according to this framework, the minimum between the cause and effect determines this cause and effect existence. And in this case, it's 0. So something like this happens if you apply this mechanism. The rough idea is to consider this joint kind of probability matrix to see whether it makes any difference when you tensor like this. So X as a 0, 1, right? And then Y as a 0, 1. And then to make a prediction about Z. And then let's say if there is a situation like Z is 0 and then 1, 0 and 1 in this case, then XY jointly is 0, 0, 0, 0, 1, 1, 0, 1, 1. Then it can be kind of a like generalized version of a multiplication here. Because X is 0, and then Y is 0, Z could be 0. And then only this is 1, and then this is like 0.5 and 0.5. That's a probability here. And then, something like this will make it completely decomposable into 2.
So the idea is, if I might ask, the idea is that there's like different realizations of the same function, and from the all possible realizations, we need to choose the most simplest one. Because like you can realize some logical function with like many different realizations, like different orders. Right. So like with Occam razors, you're not supposed to take the most short description, kind of Kolmogorov complexity or something.
It's probably related, but it's not exactly like that. The way to cut this relates to something what you probably said. The minimum cut is the one that we need to do. So for example, if there is something like this, and if you try to introduce the cut as here, right? That means that there's a huge difference between cut system versus a non-cut system. So you need to try all the cuts to find this minimum cut here. It's called minimum information partition. So if you do that, then you can identify that this CLCR in this case doesn't exist. And it doesn't add any kind of causal explanation on any of the things beyond, above and beyond the 6 units explanation of this, frog's cause and effects. And on the other hand, this, F2 frog, it has 1, 2, and then it's joined. All of them exist, and it has its own kind of explanation. Left bug detector, right bug detector, and then this super bug detector. And in this case, F1 frog, where those two things are two separate parts living together. Of course, this one doesn't exist. And this case only exists on this one, and then this one only exists. Yes.
I still don't understand the middle part. You're saying that according to the causal analysis, the specific
This one?
superbug detector is concluded not to make a causal difference,
This one is a superbug detector.
right?
This one makes a huge difference in this case, and but the third there is a value here. That's the degree of the causation. That's according to this framework. I'm talking about that. It doesn't.
It's excluded. I see.
Yeah.
I see. So like,
Yeah, this dotted line indicates what we are talking about right now.
I see.
I still don't understand what's the problem if CLCR is not detected, because they are anyway separate in the wiring diagram.
If I may, I think the idea there is that since you have the central node that detects the central big bug, the super bug, then the behavior of the left one and the right one taken together doesn't describe anything. So it's basically when we think what they mean by it's not existent, it's just their activity together, taken together, doesn't describe the behavior of superbug or something like that. So basically, they didn't develop the behavior of detecting anything. So it's as if it's not existent. If I understand correctly.
No causal power or explanation.
Yeah, there's no
explanation.
So the co-activation of those two nodes doesn't tell you anything.
But
Is that right?
The one node doesn't exist.
Huh?
The middle node is not existing.
No, it exists there, but the explanation of the left one and the right one taken together as a composite doesn't describe any behavior. I mean, that's one on the left and they all exist.
Yeah.
This one is the case where this left guy and the right guy is considered together.
Yeah.
Right. It doesn't tell you anything more or more and beyond compared to any other combination.
Okay, the graph is like very confused. Okay, now
Yeah, it took me a while to see what they're doing. But yeah,
Yeah. Well,
the dotted line is the important thing.
Yeah. This is talking about what's the role of CL. This is about the CC. This is about CR. And then this is CL and CC, center one. And then this is CC and CR. And then this is about what's happening about 3 things altogether. Now it makes sense? That's a difficult part of the supplementary material here. So the point of this frog example is that to make sure that there is something that this IIT framework can talk about is a composite mechanism or operationally. And also, we can always define this or find this even in neurons or artificial system or whatever, as long as we have this kind of transition probability matrix of each one or composite one. And then if the composite one is exactly the same as this, then the composite doesn't exist in this case. But in the case of AND, for example, or XOR, then X or Y, as if you only look at X or only look at Y, then you can't determine Z, right? You need both. And sometimes you call it as a nonlinear or something like that. But basically, all of these cases where composite of X, Y exists. Okay.
One question about we started this conversation with the 3 terms, right? Causation, prediction, supervenience. And so just going back to that right now, when we're looking at the supplementary information, they're making a difference. Did sound a little bit like prediction in the sense that we were taking the things as composites and asking, does it allow us to explain something about the behavior of the
Yeah,
frog?
yeah.
It sounds like you're saying, does it allow us to predict something about the behavior? Is that not how we're supposed to?
It's potentially yes, but then let's move on to this. Box 2,
Okay.
right? So box 2 is its title says that the dissociation between causation and prediction.
Okay, all right.
Right. And here they use this example of five neuron system, A giving common input to B and B prime, and then B goes to C, and then B prime goes to C prime. Okay, and then B can, in this case, is a copy of it. And then C is also a copy of the B. C prime is a copy of B prime. In this case, if you just observe, right, observe a single neuron recording like between here and here, then C and B prime has a little bit of delay, but it's totally possible to predict, right? There's absolutely nothing about prediction error or whatever, 100% prediction. But if you do this, intervention scheme, are you familiar with the intervention of the frame of the causation?
And Julia Girl.
Yeah, Judea power, yes. What it means is that like a TMS experiment at the level of a single neuron. So if you force this, or optogenetics force B prime to be on or off, then what happens? Right? If imagine that A is like randomly, firing, like on, so on, like this, and then you're forcing B to be always fired, then this kind of perfect prediction is no longer the case, right? Then the probability of C given B prime equal 1 used to be like this, total 100% correlation, but now it's still 50-50. So this is a way to detect that there is no causation from B prime to C. And this is the way to distinguish causation to prediction. This predicts, but it doesn't cause. Make sense now?
It's like weather report or weather forecast and actual weather. Like you can predict weather with weather forecast, but they don't like relate it. So this way, if you change weather forecast, you cannot make it like sunny tomorrow when it should be rainy.
And is it true also for a frog example with like the double bug detector configuration and so on?
So to really understand the causation, you need the intervention. So what you just observe all this, frog detector and so behaviors all the time in this environment, you can make some kind of prediction, right? But then at some point, you start to make this guy to be intervening, let's say. Then because CFCR is a mechanism here, composite mechanism, if you make it on both, without seeing this, super bug, it just starts to jump. Because this is the cause of the jump, not the super bug in the end. Right? But you can't really make that kind of prediction by just looking at input things. So input could be like left bug, but the left bug, but overwritten by this CLCR joint activation by TMS will make it jump. Because this is more proximal cause. So it's basically the same kind of story. Fine with this? Okay, then coming back to this. So this part becomes kind of complicated, but I think it's interesting. So there are 3 more example cases of XNOR. It's a bit complicated. NOR in a negation. So just to make sure. So B and then B prime. If this is 1, 1, then XNOR C becomes 1, and also 0, 1, 1, 0, 0, 0. This becomes 0, 0, and then 1. Exclusive OR and its negation. Okay. And then and operation of C corresponds to 1, 1, 1, and then everything else is 0, 0, 0. And then if it's copy, then again, it's 1 corresponds to 1. It doesn't see, right? Because this is already 1. So and its copy is 1. So if you just look at only this side, then everything is basically the same here. But this causal structure analysis says that it's completely different in the way that prediction cannot make a difference. Prediction-wise, all 3 cases are the same. Because this copy things and the XOR things says that it's 1. And then copy and the AND is also 1. And then this is copy. So everything is basically the same kind of behavior here. But the cause of this C, if you do this kind of analysis, right? It's super clear. I mean, obvious that this one is caused by this. And this one is also caused by this, right? And then this one is also caused by both of this. And this starts to be a bit unclear probably. Because this one, X nor C to be 1, if you look at this, then it has a 2 possible paths. It's either 1, 1 or 0, 0. Right? So you just need to look at either one, B or B prime, but you need to see at least one of them. And that's this X nor's cause. And then C prime is, in this case, it is caused by this one. But to jointly know C and C prime, you need both B and B prime. Because just looking at C prime only determines that the B prime has to be the same, 1 or 0, but it doesn't say anything about B. So you need to know both. So that's a sort of a level of the composite, cause and composite effects that we are that this is talking about.
So first question, is like XNOR is the same as NOR XOR? Like I was trying to compare them in the head, but
like NOR?
Yeah, it makes more not XOR and XOR should be the same. I feel like more
not NOR.
not XOR.
Not
Leave
XOR.
the first 2 letters. Like not XOR.
Yes.
Yeah.
That's the same.
Okay, because I feel like more intuitive explanations. And it's basically saying it's not either not excluding or.
Yeah.
It's much easier.
Well, whatever.
Yeah.
1, 1, 0, 0.
We have the table so here. If you do not
Yeah.
on this, you would not get the same table.
I think there's an error.
If you get not on
Yeah,
this
that's
side, you get.
the question. Yeah.
So that's not the same.
Then there is difference.
I think there's
I
a,
think this
There is mistake of XOR, yeah.
So this one.
This was regular or.
okay, yeah,
Now it's correct or.
yeah,
Okay,
yeah.
Now it's correct. So, but more on that would not give you that table.
No, that way. So this is a
No, why?
XOR.
Yeah.
And then XOR is 1, 1, 0, 1, 1, 0, 0, 0. Only exclusively OR. So this one becomes 1.
Right, okay, then it's fine.
And then this is no.
And if you take the negation of that, it will be the same. So XOR is equal to and XOR.
Yeah. Fine.
Yeah.
Yeah.
Okay,
Boolean logic. Yeah.
So about this double pass clause that you need to know there. So I hear what the kind of aim is, right? You want to be able to say that in this case, both B and B dash together, and determine that value exactly. But then if a reductionist comes along and says, well, why do I need to treat them as a composite, right? Why can I not just say there are 2 independent variables here and they have this, influence on one variable downstream, rather than saying that they form a whole over and above the kind of, the vertical level. And then I'm a bit foggy about exactly what the argument there is, something about, if you decompose it in a certain way, it will tell you different things. But like mechanistically, it seems like, if you apply Occam's razor or something like that, the simplest explanation is just stay at the lowest level and say, I have already, full prediction by treating these 2 as independent variable that determine a downstream variable.
Yeah.
So I think that, if we wanted to then say, yep, that is acceptable, but also please consider that there's also a joint causality level, which is kind of, I think, where this is going. It brings in like traditional worries of overdetermination that people like Kim and so on have done in the problem of mental causation, right? So the problem there is always like, if I say, what made me move my arm? We could say, well, it was your pack of neurons in your brain that made you do it. And then the psychologist want to come in and say, no, actually, of course, there's all the neural stuff happening, but what also caused you to move your arm is that you wanted to make the point of moving your arm or whatever. You had a full psychological level of causation also at play. And then Kim says, no, that's overdetermination. You can't have both higher level supervening causes, like vertically determined, plus the lower level neural causes. And then he says, given that we can't have the multiplication of causes for one downstream effect, we should side with the natural sciences and say it's the lowest level of causation that we should deem as the level of causation and exclude everything else. And then this is kind of like his argument of causal exclusion, that you don't, given that we cannot accept overdetermination and there's already a full explanation at the lowest level, that full explanation excludes the causation of the higher supervening level. So is this supposed to somehow show us that Kim is wrong about his argument, or?
In a sense, you're right, and it also builds on Kim's actual, formulation. So they actually cite a lot about the Kim, but it's incomplete. That's the story. So Kim's, I haven't actually read, and I have started just reading this, Kim's literature. So I'm just super naive about this, but Kim's main argument is this one, right?
Yeah.
So P is a physical. Physical mechanism at T gives rise to P at T plus 1.
Correct. Yeah.
At the level of micro. So this is complete prediction. And then at each time point, mental mind is supervenes on this physical. Right? Once you know the brain state of this T, then mental at T or some delta T is already completely determined. And then this one also determines this. Therefore, there cannot be any kind of prediction here or causation.
Correct. Yeah.
That's what they are talking about.
Yes.
This is fine as it is, and then this paper doesn't talk about this directly. But what's missing in this picture is that something like composite. How does this kind of composite or emergence arises, and how we can actually quantify? And without this level of the analysis is incomplete. That's what I think what the
I think I agree with the intuition there, that something about Kim's way of framing the things is incomplete. And we do want to make room for higher levels to make a difference, as it says. I really like the notion of making a difference. But my feeling is that in order to properly get around Kim's exclusion argument, we basically need to loosen up the lower level to be more open to other influences in a way. So right now, his main defense is the causal closure of the lower level, in a sense that it's self-sufficient. It doesn't need anything else. Right, and that allows him then to say that everything else is just a heuristic or like epiphenomenal or can be ignored. And this paper is pushing against him, but it's not touching that foundational premise that the lower level is actually complete in itself. And I would say if you remove that, if you remove the completeness criterion at the smallest level, that then opens degrees of freedom for actually the higher levels kind of like change things at the bottom level. And that, it's controversial. You can call it like top-down causation or something like that. But in a way, if you assume determinism at the bottom level, then you're basically, removing what gives you power to say that, other things can make a difference. So because it becomes epistemological, right? So let's put it this way, like we can make all this analysis and it's great and it helps our understanding. So now we understand better like how the frog's behavior works, but it's something like the way the causation is framed here is not as a mechanism in its own right, but just for us as observers to better understand the system, right?
Yeah, so that's actually clearly written here, especially in this box 2 or something like that, where the causation, box 1 probably, causation and also supervenience are all understood as the ability as a mechanism to take or make a difference here. That's the definition of the causation.
Yeah, so
here.
they want something stronger.
Yeah, but then wait, and then this another one, I think prediction can be understood as our ability to derive the future state.
Mhm.
And then the supervenience is also the assumption that I think
Yeah, so basically you, to some extent, you could resist,
this one.
yeah, you can reject supervenience.
No, you don't have to. So that's a point of here. So just to make sure, right? You made several points at the same time. One is that the determinism.
Mm-hmm.
Determinism and the causation doesn't have to be, together at all in this framework. It's all probabilistic, and also it's going to be a completely different, longer discussion about this. But determinism is not assumed at all here.
It is not the models of the paper, though, right?
No, it's also at the bottom. It can be completely, probabilistic, and IIT also requires a randomness at the bottom. So that's a slightly separate kind of discussion. So I'll just leave aside, right? And then the prediction is about our ability to make a prediction about the future based on the current. And then supervenience is our ability to understand what's happening at the, from the micro to macro. Causation is, as it says, the ability for our ability to for a mechanism to take or make a difference. This is actually a bit vague or intentionally made vague, I think. The ability of our mechanism. It's not our ability of understanding the mechanism. Because in the end, IIT says that the causation is probably fundamental. But this part is a bit unclear.
But I mean, like, just to put it graphically, like what I would expect is that your supervenience here should have a complementary figure where the arrow goes from the composite to the parts. Right now, exactly. Because right now, if you only have one-way flow of determination, it could be compatible with something like epiphenomenalism.
But
some kind of like,
wait a second. But the supervenience is always from this direction.
I understand, yeah.
And then you want to have another route.
Yes, and that's the making difference part. That if you want also to claim that the composite makes a difference, somehow you also want to be able to draw that arrow, which says that it's not just a one-way direction of making a difference. It's not just that the lower levels make a difference to the composite.
So okay,
but the other way around too.
IIT's answer or this paper's answer is basically this framework. To given a situation, under what situation this obtains or not. That's the only thing that we need, and then we don't need to talk about this. That's the answer.
I understand that part. So I'm just wondering whether it gives us what they are wanting in a way.
So what they are wanting is a kind of precise definition, a precise condition of this when this composite happens. And without that, I don't think you can't, for example, distinguish why this CLCR for this one doesn't exist, but this one exists and this one doesn't exist. It's pretty arbitrary, right? I mean, you can call it as R because there are two bodies. That's why CFCR doesn't even exist. But here, it's also one body, but CFCR doesn't exist here. But this one, CFCR exists. And then this existence of this composite mechanism CFCR is very useful for us to understand what this guy is doing. And also, at the same time, that explains this behavior at the appropriate level.
The question is mostly on the observability part. Is that right? Like if
observability part is, I would say, prediction, but if you also include this intervention and then observation, or manipulation and the observation, then it starts to go to the causation. Does it make sense?
Yeah.
Yeah.
But then maybe what Dr. Froese is saying then is that there's this observability problem where you can't completely observe the causal factors,
Completely observe.
or like you can't completely know, like you can't know just from CLCR if they are if there's a causal factor beyond CLCR.
You mean CL only and CR only versus CL together?
So you're observing CL and CR for a particular behavior, but then because that is not causing that behavior like by itself, there's some causal factor outside CLCR.
No, not outside, joint. That's the point. Simpler kind of situation is this, right? That's why I kind of spend some time. Cause of C to become on cannot be B or cannot be B prime only, right?
Yeah.
What do you say about this cause of this and operator C to be on?
The idea is that you're observing C, you're observing C and C prime.
No, just forget about C prime. C just only C.
Yeah, you can't tell anything about B and B prime. Like you can't tell both from that.
So it's not, so this next part is the quantification part, which is actually also interesting for this formers. If C is on, right, and you know this in diagram, then it has to be the case that B and B prime cannot be zero.
Yes.
Each individual, even if you don't know this one or don't know this one, right? But if this is zero, it doesn't tell you whether this one was 1 or 0, or 1 or 0. Because C is 0 could come from 0, 1 or 1, 0 or 0, 0.
So that actually
but then still also it gives us some kind of idea that if this guy is C is 0, then it's more likely to be that both B and B prime to be 0, twice more likely than 1. Probability wise. It's not deterministic, but you can tell something about it. But if you know both, it's completely, no.
Yeah, but my point was that like that's my understanding of observability, where you're just viewing whatever you recorded, but you have to infer the entire system state, which you can't infer.
Sorry.
Like the entire system state will include B and B prime or A. But you can't
B and B prime and C is the thing that you need to observe.
Yes.
But you can, we are kind of hypothesizing that we can observe everything under this situation. So I don't know what you mean by the observability in this situation.
My point was just that if you're recording C,
right,
you can't observe B and B prime.
Under that situation.
Yes.
Okay.
So like then similar point being that if you're observing some part of E, you can't like basically know everything about the system state or the vector B.
Yeah, I'm not sure whether what your concern is, but what this is kind of, this all causal analysis is kind of assuming is that we have access to all of the mechanism and also connectivity and also states. And then under that, whether we can talk about, this composite kind of emergence and also prediction into the future. So if you can't observe everything, then both this or that doesn't work. also. So the difference between supervenience, prediction, and causation only starts to make sense when we can observe everything first.
That's quite a strong requirement, right?
Maybe,
Especially for consciousness research.
maybe, but this kind of thing is also assuming such.
Maybe no, for sure. It's also
The
problematic.
physics is all completely determined,
Yeah,
or
yeah.
observable.
Exactly. That's why I'm saying that there's a way of attacking Kim that touches exactly on that point.
Maybe. I don't know whether this actually makes sense or not, or to proceed, or should we just stop here?
But
So the main takeaway from this figure, right?
Yeah,
is
yeah.
that there are three different scenarios. You can get one,
Mhm.
right? This is pretty different operators. One is XNOR, one is AND, one is copy.
Right.
And you just by observing the behavior, the final thing, you cannot determine what kind of mechanism was done. Was that the main conclusion of that?
Yeah, so you need to intervene to fully understand what's going on.
Right. Yeah. And then when you
That's-
intervene, you also cause the causation, right?
That-
You are part of the causation.
That's an interesting idea, but the idea of this causation, understanding causal mechanism through intervention is indeed, yeah, you use some kind of causation to understand what's actually is causing, and so on, yeah.
Okay. Yeah, we can stop here or we can continue, whatever you prefer. We have half an hour more.
Half an hour.
Yeah.
Okay, then
I still don't understand it.
is it better to take a break, like 2 minutes or 5 minutes?
If you need it, but we're okay. We're trying to stay.
Yeah, it's the
Usually-
usual kind of.
My love, I usually take a break after 30 minutes.
Sure, we can have a short.
Yeah, if you want toilet break.
Yeah,
Okay.
and then I'll come to the last part of this.
I support taking breaks, Tom. I think taking breaks.
Okay, good. All right, good. Break time.
Yeah.
Nobody gets it.
Mentally, we take a break.
I feel bad. I think I dozed off.
So the idea is that, like in example D, you cannot reconstruct, and if you have information about C,
Mhm.
you cannot reconstruct the B and B prime in any way. If you have, for example, E, you have N function.
But that's what I was going to say. Like, I'm not arguing against the validity of trying to sort out between correlation causation using intervention. Obviously, intervention will give you more information than just pure observation. Right, that makes sense. But the starting point of this was about reductionism.
Yeah, so integration information theory tries to make the argument that there is like something real in this composability, because some people don't.
But that
know
is the point I was trying to. So maybe you can help me try
There's only
to.
that point.
Yeah, but that is exactly the point I was trying to get at again and again, which is like, so what is it? What is the higher level that we're trying to defend here?
The composability part.
I know, but but that's still horizontal. It's kind of like horizontal. I mean, it's like flat in a way. Like we're saying that there's a system.
No, horizontal part is like time in that picture.
No.
Not in that picture. That picture is confusing. That picture is.
No, yeah, but it has different kind of links between the different variables. So if you wanted to say that these variables are, have different constraints, then you need to use intervention to sort them out.
So do they not talk about causation in general without intervening?
That's kind of pretty much discussed in this interventionist framework, building on the Judea-Pars framework. Are you familiar with that?
No, I'm not.
We have.
Huh? We have the book. Okay. We have many books. I mean, it's okay, maybe we'll wait for Tom so that you can rest.
He already knows about this, so
Yeah.
I can just say that. So let's say, if you observe A, and then if you observe B,
Mhm.
and then B, usually this one is a past, and then this is a future, right?
Mhm.
And then you were there in the quantum causation,
Right.
Like
Right.
you were there.
Yeah.
Then let's say when there's a correlation here, temporal correlation, then let's say Trump gets elected,
Mhm.
and then U.S. economy
Goes down.
improves or goes down or something like that,
Mhm.
right?
Mhm.
That's usually we informally talk about the correlation,
Right.
past to future, and then also the predictability or something that
Mhm.
uniformity across all the possible worlds.
Mhm.
But for this arrow to exist, what you need to know is about what happens if A doesn't exist.
Mhm.
If there's no A, then no B.
Mhm. Sorry.
If that's happened, then it's going to be-
Yeah, you can.
A good example is like cancer research about smoking and cancer.
Yes. You have that doesn't work, this one? The
this one. Yeah, so
Joe, sorry.
if no A, then no B.
Mhm.
Then this one is a causal condition.
Mhm.
My colleague Hayato Saigo says that for causality is without A, no B.
Right,
That's causality.
yeah. Yeah, no matter what you do, B doesn't happen
Right.
unless A.
Right.
Mhm.
That's the causality. So
Right.
but usually, when we talk about causality in the natural world, what we talk about A, B situation, when A is on, B is on. That's the only thing we talk about, right?
Mhm. Mhm.
That's really bad,
Right.
incomplete. You need something like A is zero situation. And then when A is zero, B is zero, then that's causality.
But like what to do when there is like no way to do intervention? Like we cannot do intervention on physics law, like we always hear.
Right.
Like Tom doesn't like physics law.
Right. So you're very, like right on to okay. So if there is no possibility of making this into Z, then we don't also we can't talk about the causality as well.
So that framework doesn't work for the most important question. That's the problem.
Why?
I mean, like the framework of causality that works for like smoking, like the main example in the book is like smoking research, like how to prove that the smoking causes cancer.
Right.
And you can have like people with
I see.
but we cannot like remove the soul from
Exactly.
the brain to like, we cannot make this intervention.
Right.
That's the problem.
That's a part looks most very important, right? So yeah, but that one is actually ethically impossible, right? This one is actually physically possible. Like forcing some people to actually smoke every day.
Yeah,
like, that's possible actually.
Yeah, but I mean, like we cannot like remove soul from the people because we don't know how to do this. Like,
Soul.
like some subjective experience.
Mind.
Yeah, so like
like this one.
Yeah.
Like physically here,
Yeah.
and then removing
Yeah,
this.
exactly.
That's not possible.
Yeah.
Yes, exactly. That means that this is not a causal. That's a really good point. Yes. Yeah.
Yes, sorry, in that paradigm, how will you know if, let's say, there's a causation from A to B, but if there's a factor Z also causing B?
Yeah, that's actually a really important point. And that's actually that. Right?
Yeah, exactly.
So let's say if C is also projecting to B, right? And then if you remove A, but C still is there, then B is actually there potentially. And this is a situation of shooting prisoner, right? A and C simultaneously shoot one person. And then you say, okay, don't shoot.
Yeah.
And then, but I shoot, and you get die, you die, right? And then that means that your death is not justified, yes. But think about this, more methodical, right? This is a very interesting situation of A and C, at least somebody has to shoot.
Yeah, sure. But you
And this means that it is a joint cause of death.
but you can't ever know how big your joint set is.
No. That's the thing. That's a part of this causal intervention. For example, shooting case, we can at least, think about, also simulation wise, or, physically there is a possibility of I should, you should, I should, you don't, he should, I don't.
I feel
and
like
both of us do not should.
this is leading to something now. What's it leading to?
Right, that's this one, yeah. Yeah, but intervention is assumed to be possible, logical. But impossible kind of, intervention is like that. Like, brain is like this, but you just remove the mental. That's not possible, I think. At least we don't know how to do it.
If it happens.
Oh.
Lobotomy.
Yeah, physical.
Okay, now let me try to see if if I try
But
to.
it, bottom, sorry, Tom, no, continue. Sorry.
So going back to their proposal, I have a lot of sympathies for what they're trying to achieve. And I also agree with this part, and I also agree with the importance of interventionism to
Right.
sort out causation from mere correlation and things like that.
Right.
My feeling is that it would be difficult to find someone who disagrees with this analysis, right? That if I want to understand how a system works, I need to go beyond correlations. Nobody will deny that, right? I think they're all on the same page. And interventionism is one way of doing that. To actually say, this is my hypothesis, that this is not just a correlation, but some kind of dependence relationship, in a causal way. So if I remove one of them, I should see some difference, right? This is making a difference. So they're also all agreeing with that. I think the point that I was trying to get a little bit, unclear about is what is the role of compositionality in this. So in this form, it feels like we're still somehow at the same level of description. So we're just saying the system could be organized in different ways, and some of those organizations could be hidden from us if we just observe the external behavior, and we need to somehow intervene in the system to sort out the space of possibilities that could give rise to behavior. Again, I think that most people will probably agree with that. But I also feel like maybe this is where my misunderstanding is, but I think what they're also trying to say is that there might be a way of saying something about causality at higher levels of descriptions. So just a classic example would be the organism as a whole, right? So there's a lot of literature that an organism is not just, the sum or set of all its individual parts, but somehow, let's say, us as multicellular organisms give our own direction to all the parts that can't be derived from just all the little parts doing their thing. That's where I don't feel that this framework yet has quite touched on that.
Yeah, so I have to say two things. And one is that, whether there is no possibility of the opposition, it also relates to the second one, but I'll answer the second one first. So the clear case of situation that this kind of analysis say is, for example, what exists as a human is really the core part of the brain, and then everything else is kind of a servant sort of to this. At least in the moment, in some moment.
Still sounds a little bit like reductionism, no? I mean, like at least
maybe, but maybe a different driver, right?
Okay.
So if there is this, split brain patient, right, who is completely, similar in the left brain and right brain, hypothetically, and then it produces a really gigantic, so-called integrated information on the left and on the right, separately. Then this is a case where two individuals living in one brain or one body. And then the other case is that when these people's body contains lots of bacteria in the gut, right? But each of this is actually possible to cause or intervene, and then that's make a really almost minimum effect onto the brain. At least in the time scale that we are talking about. In the long run, yes. If I change my gut system into something like an autistic person, there is some kind of theory saying that I may become like more autistic and so on, right? So there isn't a long-term effect of that, but that's supposedly this one gradually kind of eating up, and then there is some kind of thing going on here, and then eventually that happens. But in the moment, you can actually intervene here at all, but does not affect anything here,
Mhm.
which is very similar to the situation of this kind of situation.
Mhm.
You can make lots of intervenes here, but doesn't affect them here.
Mhm.
So it is a sort of demarcation kind of solution when this entire thing actually exists and when it doesn't.
Mhm.
So this sounds very similar to like free energy Markov blanket.
Many people point out that, but I think there is a difference, and maybe your idea of the free energy and the Markov blanket needs to be also clarified. But yeah,
Yeah,
There
I think
can-
this is very strange stuff.
Yeah, but this just going back to this part,
Right.
so because you said that at least it would have some, if we apply this analysis, it would turn out that the fundamental causal structure is some part of the
Right.
the brain, right?
Right.
So I think for many people that would be a neurocentric reductionism. So if you go with Dennett's distinction between personal and subpersonal, the whole idea is that in order to preserve meaningful folk psychological explanations, like I did it because I believed it was the right thing to do, that sort of
right,
stuff.
right.
We cannot allow complete reductionism to something that is happening just somewhere in the brain. Ideally, we would like to be able to say that both things matter, right? Of course, your brain is necessary and matters, but we'd also want to say that what you believe as a person also matters. And if the beliefs are shown to be non-causal in this
Right.
framework,
Right.
for many people, I think it would be considered a reductionistic framework.
So I think this is probably close to what you're trying to say.
Okay.
Okay, but the IIT actually, this is a causation paper, so it's not directly talking about this, but idea is very close to this. IIT says that our consciousness is identical. And
Mhm.
this is a part that I'm not 100% subscribing to, but it's their hypothesis, okay? Identical to this causal structure.
Mhm.
That is exactly the same as a consciousness.
Mhm.
And that's the one that exists.
Mhm.
But the thing that doesn't exist is not this, 1, 2, 3, 4, 5, 6, 7 elements. 7 element implements this cause effect structure.
Mhm.
But what exists first is the consciousness of this system. And that is completely identical to this cause effect structure.
Mhm.
And this cause effect structure is like this way.
Mhm.
The part that I didn't explain is this pink thing. It's called the relation. How this mechanism actually combines together, and also how each of the mechanisms exists.
So maybe then we can use this formalism to specify the alternative stronger hypothesis. So let's assume that we're not agreeing with the identity claim and say that consciousness itself is something more than just identity with this particular causal brain structure. Or your person. I mean, I can say there's a difference between your personal level description compared to the subpersonal. We could go within it. Then what that would mean in terms of your diagram is that even if I include all the parts in my explanation, they would not be sufficient to give me 100% understanding of the causation leading to the behavior.
Right.
There's something else that I'm not capturing. Even though in principle I'm measuring all the variables, still something is not giving me a full account of the ultimate behavior. Maybe we don't know what it is, but at least you would, if it gives 100%, then there is no other thing, right? Then it's ruled out. This is like Kim's exclusion argument in a way, like methodology applied. If Kim is right, then we should be able to do this and get 100% causation analysis done. And if there's something else, then we should not be able to do this.
Exactly.
That's interesting. At least there's a formalism that you could phrase this carefully.
So just to make it a little bit more concrete about that kind of hypothesis, what it can say also is that if we can transiently make our brain into something that disrupts this kind of structure, then the prediction of IIT is that you will lose consciousness. Even though the structural element wise it's the same.
And we have to be a little bit careful because it could be necessary condition, but not necessarily sufficient, right?
Right.
So
I mean, this is experimental prediction, so maybe their interpretation theory is a bit different, but that's something that this IIT actually can make a.
So this is like for IIT, this causal structure is necessary and sufficient for consciousness because it's identical with consciousness. someone might still could say a more looser story would be to say this causal structure is necessary for consciousness, but not sufficient.
Yeah, that you can say that, yes.
So then still, if you knock it out, unconsciousness will result.
Yeah.
But it has the implication, the additional hypothesis, that even if you could specify completely at that level of description,
Yeah.
you would not be able to with 100% know what's the behavior.
Yeah, you're right.
But it seems like the idea that it's like not possible to have philosophical zombies in IET. So like if you have this structure, the consciousness will arise. So it's also sufficient.
So that's exactly, that what you said.
Yeah, but it is sufficient, right?
Yeah.
No, wait. What IIT says is that if there is this kind of causal structure, then
Consciousness will
that actually gives rise to, it's identical to particular kind of, experience. So zombie doesn't exist.
Yeah.
Yeah.
But that's
But
all
it is-
what's needed according to IET. There is nothing.
That's why I said it's necessary and sufficient conditions for that.
Okay.
But this is a part that I wanted to say about this really small kind of manipulation of this way, of this structure can make this system into zombie. So one possibility is something like change from this to this, right? The minimum difference between this and this is that cross activity here, right? So if we have a system like almost the same up to sensory, but motor-wise it's like this, then suddenly I think this becomes like an F1 frog, because joint thing here doesn't exist anymore. So it only exists this as this one, CL, and also this CR. So this means that, like cross connection from motor cortex to the muscle, motor cortex to muscle is just kind of, ipsilaterally disconnected here. And then this will lose consciousness. This becomes like this type of the consciousness. It's almost minimum. You don't have three things. You have only one after each time, which doesn't feel much probably. Does it make sense?
Yeah. But there is always central part in IET.
Right. The maximum. So this one is a maximum. It's bound together, right? Through this pink thing. But this and this is not bound together at all. It's completely joined, and this joined.
All right. I think it's a good place to finish, maybe. Yeah. Okay. All right. Thank you so much. Thank you very much for talking us through the paper.
Yeah.
And it was not your own paper, so we made you suffer.
I like this paper actually, and also I wanted to go into the more detail about some of the causation stuff. So.
But yeah, so good. I think the last thing that now I understood too, that's using this, you could specify a kind of strong downward causation condition in which this complete analysis would not allow you the maximal causation story.
It potentially depends on how you define a downward causation.
Yeah, like when you say composite here, really like saying that something happens like at the level of the whole, which has no equivalent at the lower level. Like it can't be like redescribed somehow.
Right.
So for example, you might say a goal, like if you want to take it like in terms of teleologic as a serious cause in its own right that has conditions of success and failure and so on, then that can't be derived from purely physiological states of affairs.
Thank you, Sharon.
And this is
It's still pure physiology, but at the level of this composite.
Yeah, I understand. For this story, it stays at the level of the physiology and introduces a composite cause. It's a little bit like Peter says in informational causation or something like that. I forgot what the name is, but basically he says neurons are not physiologically caused to fire; they're informationally caused because it depends on the particular pattern of inputs that they receive.
Maybe that's kind of related, similar.
Yeah, I think so. That's kind of similar to what this is about.
Potential.
Which is that there's a composite relationship, and that composite relationship has a logic to it, and we need to figure out what that is. And it's not a purely directly physics style of billiard ball causation. That's what the compositeness means, basically. There's multiple factors that can interact.
Right.
But then I'm saying, like, then on top of that, if you wanted to bring in things that Kim cares about, like mental causation, then you have to basically bring in factors which don't have an easy way of being put as just another node in this graph, basically.
Yeah, the about mental causation, I mean, between physical to mental, I don't think this one tells us much. And that's because, as he,
Yes,
said,
identity, yeah.
We can't just manipulate
Yeah.
one, fixing one and then barring the other.
Well, that's why people in science of consciousness have all these things about, optical illusions where the visual stimulus is the same, but your experience of it, like, is dynamic, for example, and things like that.
But
Like
at the same
oscillating.
time, also the brain also changes, right?
It's true. Yeah. Yeah, so I don't think you can ever have a complete static world with dynamic experience, no.
I mean, the thing is whether it's possible to dissociate or completely dissociate the physical from mental,
Mm-hmm.
and that's not possible.
Mm-hmm.
And that's what we are also kind of agreeing, right? Like, that zombie doesn't exist because
Mhm.
we can't have this kind of arbitrary mapping from physical to mental.
That's true, but someone who's a skeptic could say that because this is a necessary and sufficient condition that's based on identity, I could conceive of this as a zombie scenario, and it would make no difference.
It's fine, but whether we can do things or not is a separate matter, I think.
Because identity is a tough one. Like, identity means there's no difference made.
Right,
It's the same,
right.
no difference.
So my own, take is that not to start with the identity, but starting to recognize these two things exist,
Mm-hmm.
and then to utilize category theory to see whether there's a mapping from one to the other,
Right.
and then the other to the other, and then to
this
see
is
whether
exactly
it
what I mean.
becomes
Imagine now, this is the physiological level. We don't know what the relationship of this is with the, let's say, phenomenal experience. So let's just posit another node here. We don't know how it's related to this. Call it phenomenal experience.
But just to make sure, right? So when you talk about the physiological, what I and also an IIT says is this, kind of diagram level.
That's right.
Entity plus connectivity.
Yeah.
And then cause effect structure
Mhm.
is the one that is unfolded from here
Mhm.
to make sure something like this, this 3 units and then 2 units and then
Mhm.
another one to be kind of related in this kind of way.
Mhm.
So this is one way to kind of do this,
Mhm.
but this itself is most unique, and then this is identical to this
Mhm.
consciousness of this particular field.
Mhm.
So physics is just one way to implement this cause effect structure, and this is more important than this one.
Mhm.
And this is probably something that you mentioned as some kind of node, right? In between this to that. And I don't think we are talking about identity about this at all. Identity is here.
Yeah, that's still fine. So it's like it's the formal properties of the system. Yeah. It's a little bit like, Varela people saying consciousness is identical with the order parameter of neural oscillation.
Yeah, that's fine. That's from brain you extract something,
You're right.
and that one is identity.
That's right. So
That's exactly.
yeah. So like we said, like, Varela does this in dynamical systems theory, and this is more kind of information theoretical analysis, but the idea is the same. You start from the brain, you extract some kind of formal properties, and that's what's identical with consciousness. But what I'm trying to say is that instead of having this identity relationship, so this identity relationship means that technically, if we account for everything here, everything should be explained 100%. Nothing
From here to here.
Yeah.
Yes.
Giving us a complete explanation of behavior.
That's correct.
Now, if this is not the identity relationship, okay, then it's possible that this one only gives us, let's say, for example, 90%.
Right.
And then we can posit the hypothesis that the extra 10%, somehow, we don't know how, is about the relationship between the conscious and this.
Cause effect structure.
Some interaction, not identity.
Right.
Some extra interaction term that we cannot directly measure. Because we cannot directly measure.
It's plausible, yeah, but I don't know existence and also how do we go about it? So yeah, you may be right, but way I see it is that because this is, if this is only like 6 or 7 neurons, and it's already super complicated, right? So that in the case of brain, it's super complicated. So what we are doing is to measure the structure of this consciousness in some limited case, let's say in the case of the color similarity structure. And then if this kind of similarity structure doesn't correspond to the similarity structure of this thing, many of different kind of structure like this. And if this and this is already different, then there's a way to unfold this brain to this one is wrong. Or some kind of difference exists between this structure and this structure. But we call it as a Fourier structure, and this is a causal structure, and the mapping from here to here and here to there is the project that we are trying to do.
Yeah, I understand. So you're basically at the moment you're betting on some kind of structural isomorphism between the two spaces.
Yeah.
Yeah.
Eventually, yes.
That's what the identity relationship, would suggest.
Right.
Yeah, and but I'm just saying that, and you might be right, but it's a specific subset in a larger hypothesis space where this interaction is not an interaction but an identity relationship. And if that was not the case, if this is a variable, actually, there could be some difference between these two, then it could show up actually in your measurements as some certain unpredictability still remains, for example.
Maybe, yeah.
And it fits with what we know about neural entropy and brain activity and things like that. So typically, cognitive effort this can be tracked by neural entropy in the kind of Shannon information thins, or if you kind of like look at what happens under anesthesia, if people do a cognitive task, then actually, brain complexity can be recovered even while they're falling unconscious.
Yeah, so that's fine. I don't have any problem with that. But IIT's answer to that is that it's just because you are unfolding this physical into something that is just wrong. If we first start from here, right? If we explicitly hypothesis this is some kind of mathematical structure, then IIT's hope is that there can be some kind of mapping from this to that. That's already one-to-one. But entropy or information theory or complexity theory, that's already known to be non-identity.
Okay.
So
one more point about Kim.
Yeah.
I think actually what you're doing in a sense is realizing his ideal project. He thought that there was no chance of doing strong mental causation story, but he really wanted to defend mental causation still. And then his solution was reductionism. He said, the best way of defending mental causation is to assume that the mental is nothing but the physical. Because we know the physical has causal powers. Therefore, if we can show that the mental is the physical, then we have shown that the mental also has causal powers. So by positing the identity between your causal structure and the phenomenal space, you're basically exactly realizing his vision of how to get consciousness to be causal.
I see. Is that the new book, like 2005 or something?
Yeah, that one. But it's
Physicalism as crossover or something like that.
physical, as close as we can get it, or near enough, or something. Yeah. But that subtitle is important because he thinks actually consciousness is the only exception for that. So he thinks we can do all the reductions that we want in terms of cognition, but not for consciousness. And he thinks it's because the hard problem of consciousness, of how our behavior could be sensitive to phenomenal qualities, is unsolved. And therefore his project remains incomplete. So if what you're doing works out, it's kind of like the completion of his project.
I see.
But it is a form of reductionism. That's what I was trying to say earlier in the seminar. So for him, he calls himself a reductionist because he wants to collapse the distinction between the mental and the physical only down to the level of the physical. But it's a cool book. I highly recommend it.
Yeah, I'll try to. Why not? Thank you.
All right, it's good. Thank you. Thank you, record it.